Welcome back. To begin lesson 3, I wanted to review some of the first things we learned in lesson 2, deciding whether terms are like or unlike. And then we did some simplifying. We also did solving, but I want to get into the solving a little bit more before we do the solving on the test. So we just need a little more practice before we do those. This is the practice test. As I told you, it's listed under the first day of class on the Canvas homepage. It's called the Module 5 Practice Test, Module 5 Test Review, and it's listed under Monday, January 27th. In case that you have not copied it yet, this is what I make your test off of, your test in ALEKS. So I go, oh, I need a problem that looks like that and one that looks like this. And I just go down and I make the practice test off of this. And the word problems, same thing. So what I do with the word problems is I do 2 of every problem. So I'll do this one with you in class, and then I'll let you guys do this one on your own. And there is an answer key and videos. I'll tell you about those as the test gets near. And then I'll do a problem like on the test, and then I'll give you one to do on your own. And so each day we're going to practice and do problems. By the time the test comes, we'll have covered almost the whole test in our warm-ups. So this is what even in class I do. When the students come into class each day, there's a warm-up with problems from the practice test to practice on to make sure that you've learned everything from the previous lesson. So go ahead and turn off your video and do 2 and 3, and then turn it back on, and we'll see how you did. Okay. Okay, so for number 2A, we learned when we were doing these in class in our notes that the letters are supposed to be alphabetical order. So the first thing I would do on this one is rewrite it so that it's in alphabetical order, and I can inspect each one carefully then. So to be like terms, remember they have to have the same variables and the same exponents. These do. They're both x to the first, y to the first, after we put that one in the correct order. So these would definitely be like terms. Next one, we have already alphabetical order, x and y, but this is 2x, x, y, where this is 6x, y, y. You can see they do not have the same variables because this one has 2 x's and 1 y. This one has 1 x and 2 y's. So these would be considered unlike terms. I would never be able to add or subtract those 2 terms because they are not alike. And on the next one, we have 2x squared y. That one's already written correctly. But this one has been expanded, so you need to contract it to see if they're the same. I see there's, first off, leading coefficient is negative 3.4. There are 2 x's, so that would be x squared and 1 y. So once you get it in that form, it's easy because you want them both in the same form. So you should either write this one xxy and this one xxy, or write them both with variables. So the x's are both squared because there's 2 x's here, and there's only 1 y in each problem. So we can see, yes, they are like terms. So don't jump the gun on these. Sometimes you have to do a little simplifying. Just because they don't look the same don't mean they aren't the same, because these didn't look the same at all. But once I clean this one up and said, oh, there's 2 x's, so put a 2 with the x, 1 y, then I can see clearly that their variables and the exponents on each variable are the same. Okay, simplifying. So when we're doing order, remember they have to be alphabetical. So I know you guys don't use dictionaries much anymore. We all use our phone. But alphabetical would be the order they would appear in a dictionary. X would be first, XY would be second, Y would be third. And then constants are always last. So as you're combining your like terms, do them in the proper order. So first should be the x. So there's nothing to go with it. So I just write negative 4x, but it's the first alphabetically because x comes before xy. Xy would be second. And so that would be a 7xy and a negative 15xy. So when the signs are different, we subtract. 15 minus 7 is 8. And keep the sign of the larger, so negative 8xy. And we never touch exponents or anything when we're adding and subtracting. We add two like terms, we get another like term. Then would be the y, alphabetically. X is first, xy second, y third. There's nothing to go with it. So that would just be plus y. And then last but not least, we'll do the constants. Constants are always at the end. Positive 3, negative 5. 3 minus 5 is negative 2. And there is my simplified polynomial in alphabetical order, as all of your answers should be in algebra. So x first, xy second, y third. And there's my answer. I forgot to turn my phone off, so let me turn that off a second. Okay, so that's our warm-up for the day. So let's go ahead and start our lesson. We left off on page 4 in our note packet. We just finished solving the equations. So we have the sum of two numbers, and it's asking us to write an algebraic expression or equation, is 9. One of the numbers is 2. How do we find the other one? So sum of two numbers is 9. One of those numbers is 2. So we could do this. X plus 2 equals 9, right? So two numbers added together give me 9. If 9 is one of the numbers, or excuse me, if 2 is one of the numbers, how do you find the other number? Minus 2, minus 2. So x equals 9 minus 2 is how I would find the other number. Or x equals 7, of course. Couldn't type that in for an answer because it's not simplified. So x plus 2, two numbers equal 9. One of the numbers is 2, so I put 2 in, and I could have put 2 first or second, it doesn't matter. Do the opposite, and I can see the second number is 9 minus 2, or the sum minus the first number gives me the second. The sum of two numbers is 9. If one number is x, find the other number. So I like to use x and y for this. Just helps me visualize it. So the sum of two numbers, and the two numbers aren't the same, so I just used x and y, is 9. One number is x. What's the other number? So what I'm doing is I'm trying to get y alone. How do I get y alone? Subtract x, subtract x. So the second number is 9 minus x. And isn't that the same thing we wrote up there? And we talked about this when we did the word problems the other day. I said there's always two types of word problems. One has the word than in it, so you call that your x. The other one is where they give you the sum. Anytime they give you the sum, it's the sum minus the first number to get the second. The sum minus the first number to get the second. So if this was 9 minus 2, when one of the numbers is 2, this is going to be 9 minus x. So we would say, if we were writing our variable statements, we'd say x equals the first number and we'd say 9 minus x is the second number. So when you find x, in this case they told us it was 2, you go 9 minus 2 to get the second number. If the first number was 6, then you'd go first number 6, the second number is 9 minus 6, which gives me 3. And we know 6 and 3 do add to 9. So anytime they give you a sum problem, the first number is always x, the second number is always the sum minus x. And you're going to see that's an important thing in our word problems later on in the chapter. This is exactly the same thing. We have a 9-foot rope, and it's cut into 2 pieces. If one of the pieces is x, what's the other piece? Well, if this piece was 2, you'd go 9 minus 2 and write 7. If this piece was 5, you'd go 9 minus 5 and write 4. So if this piece is x, you go 9 minus x. So it's just like here. X is the first piece. The sum minus x is the second piece. So anytime you know the total of something, the total of 2 numbers, the total of the 2 pieces, one piece is always x, the other piece is the sum minus x, because this means the 2 pieces add up to 9. Express the length of the other piece in terms of x. Yes, so that would be your answer right there. Okay, we're going to use the same thing on this next one. So the Missouri River is the longest river in the United States. I would never have guessed that. I always thought the Mississippi River was the longest. I grew up in Iowa where one borders the Missouri River, the other borders the Mississippi River. And we always went to the Mississippi River. It was a huge river, so I guess I just assumed it was the longest. So Missouri River is the longest. The Mississippi River is 200 miles shorter than, remember how I said they're either going to be total or they're going to have the word than. So we learned the other day in lesson 2 that if then, no, this was lesson 1, by the way, sorry. Then, whatever follows than is our x. So Missouri River is going to be the x. So I guess this one, it would probably be better. Oh, it says to use r. Okay. I was going to say it would probably be best not to use m because they're both m's, but they told us what to use. So because Missouri River follows than, it's the r. So we write r equals length of Missouri River. Okay, so anything that follows than is your variable. And they told us to call it r in this case. So Missouri River has to be r because it follows than. It says the Mississippi River is 200 miles shorter. Well, shorter means subtraction. So we're going to take 200 away from the Missouri River's length. So the Missouri River minus 200 equals the length of the Mississippi River. So I don't know if this is an Iowa thing or if this is how everybody learned it, but I remember they were teaching us to spell Mississippi when we were in grade school, and they said M-I, crooked letter, I, crooked letter, I, humpback, I. Did you guys ever learn that? I don't even know who came up with it, but isn't it weird that I remember that like so many years later? So M-I, crooked letter, I, crooked letter, I, humpback, I. Boy, us Iowa hicks. So R minus 200 equals length of the Mississippi River. And it says express the length of the Mississippi River in terms of R. That we did. So got to see both types of your word problems there. When it's a total, one will be X, the other one's the total minus X. One will be X, total minus X. When there's the word than and they don't give you the total, whatever follows than is your R, then you read Mississippi River is 200 miles shorter. So take the Missouri minus 200, and that's the length of the Mississippi River. And now you'll never misspell Mississippi again. Okay, so just a little, there's a couple different themes that I like to just keep coming back to just because they're so important in the class. One is translations, one is word problems. So you'll see that theme that each day I try as much as I can to address both of those in addition to the new lesson. So the more we review, more likely we'll remember. So we talked about reciprocals the other day. The reciprocal of 3 is 1/3. The reciprocal of -4/3 is -3/4. We learned that reciprocal means flip it. And if it's a whole number, you just put it over 1, and then you can see why it flips to 1/3. But we didn't talk about this. When you multiply reciprocals, you get 1, because this would be 3 over 3, which is 1. This would be 12 over 12, which is 1. So anytime we multiply reciprocals, it's 1. And that's kind of important to understand that operation when you're doing multiplication and division, because when there's division in the problem, you multiply both sides. When there's multiplication in the problem, you divide. So in other words, addition and subtractions are called inverse operations, while multiplication and division are also inverse operations. So the opposite of addition, subtraction. Opposite of subtraction, addition. Opposite of multiplication, division. Opposite of division, multiplication. So that's what inverse operations are, because we know when we solve an equation, we always have to do the opposite. And that same rule of equality applies. If you multiply both sides by the same number, you haven't upset the equation. Or if you divide both sides of the equation by the same number, you have not upset the equation. You've maintained the equality because you did it to both the left and the right side. So the rule is, whatever you do to the left side of the equation, make sure you do the same thing to the right side. So for this one, I look at it and I go, oh, that means division. We learned to write all of our division problems with a fraction bar. So the opposite of divide by 3 is multiply by 3. And this is where that reciprocal property comes in. This is really 1/3, where this is 3 over 1. So those cancel. They undo each other. So I get X equals 15. So the opposite of divide is multiply. 3, and you can think of this as a big division sign there. 3 divided by 3 is 1. So 1x, which is x, equals 15. And then the checks are the same. X over 3 equals 5. Write your original problem. Put your answer in for x. 15 over 3. Does that equal 5? 5 equals 5. Ding, 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 ding. But remember, this isn't your solution. This is. What's required here is these must match, which they do. So then once we get matching, put 15 in. So 15 is our solution because we got a true statement at the end. Okay, so let's do one more and then I'll let you guys try a couple. So this is times. Remember, anytime there's not a symbol there, we can assume that's a times. So the opposite of multiply by 12 is divide by 12. 12 divided by 12 is 1. So we're left with 1x, which is just x. 36 divided by 12 is 3. Check it just like all the rest. 12 times 3. Whoops. Kim, you forgot to write the original first. Sorry. Jumping the gun. So there's the original problem. Put your 3 in place of x. Is that equal to 36? 36 equals 36. Boom. That means 3 is our solution. Nice, huh? So just as easy as addition and subtraction. So I'm going to have you do the next two. And I'm going to tell you on D, there's 2 ways to do it. You can do it as a 2-step problem, or you can use your calculator and do it as a 1-step problem. So that's the hint for D before you try it. On C, and there are fractions on the test. You can look on your practice test and you can see there's fraction here, there's fractions here, there's fractions here, there's fractions here. So you have to be good with fractions on your calculator. So make sure you practice on these before you go over them with me. On this one, step number 1 should be to flip it. As I said in the last lesson, in lesson 2, we always want our variable on the left before we start. So you simply just flip the equation over and start from there. So solve each, check each to verify the solution, put your answer in solution sets. So go ahead and do C and D, shut off your video, and then come back and check with me. And the best way to learn is practicing. Okay, on this first one, that is times. The opposite of times -8 is divide by -8. And some students will write +8 there. No, that's addition and subtraction when you change the sign. This is opposite of times -8 is divide by -8. So divide both sides by -8. 2 negatives make a positive. The minute I see 2 negatives, I immediately make a positive because I see how many errors students make when they don't do that. And 8 divided by 8 is 1. So we get y equals 1 negative answer. 56 divided by 8 is 7. To check it, we must go into the original. Don't flip it over for the check. And we're going to put -7 in. So is 56 equal to -8 times -7? And by the way, I grade every single person's test. Everyone. You scan them to me and I grade them. So you need to make sure all your work is shown. Because if there's not work and you just went, oh, I know that answer is -7. No. I want to see the work. Why? Because pretty soon our problems are going to get gigantic. And you can't do them in your head. So we start out with the easy ones. Maybe you can do them in your head, but do not do that, because then that won't teach you the steps for when they get harder. So everything I show you, I'm expecting to see on your test. I'm modeling the behavior that I expect to see on your test. So just FYI, make sure you show all your work. And all of that's in the syllabus, but I just want to make sure everybody knows. So 56 equals 2 negatives is a positive. 56, ding, 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 ding. That means -7 is indeed my solution. Nice, right? Okay, so hopefully everybody did fine on that. So this one has 2 ways to do it, and I'll show you both ways. So the first way that we do this one is pure calculator. And I frankly don't care which way you do it. I think you should probably be able to do it both ways. Actually, let's do the first way with algebra. We'll do the second way with calculator. So we got a little bit more room over here. So with algebra, I can do this in 2 steps. I can say, oh, what's the opposite of divide by 3? Multiply by 3. So I multiply both sides by 3, and that gets rid of the fraction. So then I'm left with 2x equals 24. And then the opposite of times is divide. X equals 12. So that's one way to do it. And some students tell me that they learned in high school how to multiply both sides by the reciprocal, 3/2, 3/2. That's fine too. I just think a lot of times students don't understand why they're doing that, multiplying by 3/2, but it's this reason. Because you want the number in front of x to be 1, so you multiply by the reciprocal. So the reciprocal of 2/3 is 3/2. This way just shows you the steps a little more clearly. Opposite of divide, times, 3's cancel, opposite of times, divide, 2's cancel. So either way, fine. The math way using a calculator is shorter, yes, but are you going to be able to do it this way when they take your calculator away in Math 156 and say do this test without a calculator? Which usually about 3 tests have no calculator or just partial use of a calculator. So I like to make sure I know how to do both ways. So the calculator way is this is times. So the opposite of 2/3 times x is divide by 2/3. And then in one step, I can type it right into the calculator. So 2/3 divided by 2/3, I know everybody knows that's 1. So watch how I type this in so that you make sure you do it correctly. So this is 8 and this is a division sign. So 8 division sign. Then I do the fraction bar here. You can't do double fraction bar. So this is division. This is the fraction bar. So 8 divided by 2 fraction bar 3. So that's how you would type that into your calculator. So must be division there, and then use your fraction bar key for 2/3. And ding, 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 ding. Same answer I got by doing it by hand. And like I said, I would make sure you understand both ways. If you're in a hurry on a test and you want to use a calculator, great, but make sure you know how to do it by hand as well. To check it, write your original problem, 2/3 x equals 8. Plug your 12 in, is 2/3 times 12 equal to 8. 2 fraction bar 3 times 12. There it is. 8 on the left, 8 on the right. Boom. That means my 12 is a valid solution. Or is the correct solution, I should say. So hopefully you guys did okay on those. Okay, let's do these last 4 and get this video over with. So we have times here. So if we want to do the calculator way, we would do, and I'm not going to do both ways, I'm going to do mostly calculator on this, but if you wanted to do the other way, you'd multiply both sides by -6/5, -6/5. So I'm going to do it the calculator way. The opposite of times is divide. Divided by -5/6, divided by -5/6. Because anything divided by itself is 1. So 2 negatives positive. This is now 1, which is my goal. I need just x on the left. So this one, I have to remember when I'm typing it in, that's a fraction bar. This is division. That's a fraction bar. So let's practice typing that in. And you guys have a lot of fractions on your test, so make sure you're following along with your calculator. So negative sign, negative sign. So we have negative from the bottom. 3 fraction bar 5. Then I use the division sign. And then negative 5 fraction bar 6. So that's what your calculator should look like. This is the division, because the opposite of times is divide. These two are fraction bars. We know the answer is going to be positive, because 2 negatives is a positive. And it is positive 18/25. And you would found that same answer if you had multiplied both sides by -6/5, -6/5. Negative times a negative, positive 18/25. And probably doing it by hand is the fastest way. Like I said, I would make sure you know how to do both ways. So that one we just did with the calculator. Okay, to check the work, -5/6 x equals -3/5. And I need to put 18/25 in there. So -5/6 times 18/25. And is that equal to -3/5? So again, calculator to our rescue. So -5 fraction bar 6 times 18 fraction bar 25. So that's what your screen should look like. Hit enter and let's pray for that. Ding, 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 ding. It's there. Love it, love it, love it when you check it and your check is correct. And so that means 18/25 is my solution. Okay, for F, we did one of these earlier. We said that if there's a negative in front of the x, precede it with a 1. So -1 times x. That's how I would rewrite it on my paper from Alex. So I would rewrite it as -1 times x equals 7. And then I have no question in my mind what the first step is. Opposite of times is divide. So divide both sides by -1. Double negative is positive. 1 divided by 1 is 1x. A positive divided by a negative is -7. So super easy to check. I mean, super easy to work. And to do my check, I write the original problem. So now this one you got to be careful with. I see students mess up on this. That negative stays there, and then you're plugging in -7. And you can't ever have two signs side by side, so you must put the -7 in parentheses. So this is the negative from the problem, and then we're putting -7 in for x. And we want to know, does that equal 7? Like I said, double negative, the minute you see it, you make it plus. And the reason why it's plus is because that's read opposite of -7. The opposite of -7 is 7. So that's why we're allowed to do that. It's when there's a negative in front, it's read opposite. The opposite of -7 is +7. Because a lot of students do the plus and they have no idea why. Oh, I know 2 negatives is a positive. But understanding why, that's pretty important. So this is read opposite of -7, which is +7. Okay, shut off your video, do the last 2 problems, then come back real quick and we'll get this video over. So go ahead and do those 2 on your own. Don't forget to flip this one over. Don't ask for checks on these, so you can just solve them if you like. If you have time to check them, go for it. On this first one, we first want to flip. We need the z on the left. And like I said, it's not that important in equations, but it's huge in inequalities. So we establish the habit. always put our letter on the left. Then when we get to inequalities, it's already a habit and we don't have to do something that we haven't been doing. So divide by 5, because the opposite of times is divide. Divide by 5. So z equals a negative divided by a positive is negative. 15 divided by 5 is 3. 5 divided by 5 is 1. That's a little shortcut I learned somewhere along the way, that when both numbers are divisible by 5, you can do it in your head. But of course on a test I would never do that. I would verify it in the calculator. So using the bottom key, negative 15.5 divided by 5, there it is, negative 3.1. And we're not checking these. I think we've done enough checks to make sure you know how to do them. And then last but not least is the same one that we did above, except it's a double negative. So we have negative 1 times x. So when I see this problem in ALEKS, the first thing I would do is rewrite it on my paper like this. So negative 1 times x equals negative 3. Opposite of times is divide by negative 1. Double negative, double negative. Do that first. There are no negatives left in the problem now. So there should be no negative answers. So 1 divided by 1 is 1x, which is just x. 3 divided by 1 is 3. And that one's easy to check in your head. Opposite of 3 equals negative 3. Done. So you put 3 in, the two sides match. Okay, that's a good place to stop for the first part of our lesson 3 notes. So I'll see you on the next video.